can't beat the in-person interactions, the lunches, the dinners. The quality of the people that you meet over coffee here is just phenomenal.
World. First, I'd like to say that I'm very, very excited to be here, and I'm very grateful and honored to have your time and your attention. Well, a little bit about me. First things first, I like C++. I'm also a graduate computer scientist for quite a while now. And I've been working with computers and programming and trying to find ways to practically apply them in everyday life. I'm particularly interested and excited about energy-efficient computing. My contacts, I'm Benson Norinat on Twitter. I'm Mathew Benson on the Hackidam Mastodon server. That's my email. GitHub, Mathew Benson code. And I usually hang out on the CPP Africa Discord server as Mathew Benson KE. So, what will we be talking about today? First, we're going to explore using C++ on older generation hardware. Second, we'll look into C++, learning C++ as a language. And third, we'll talk a little bit about tooling, especially on resource-constrained systems. So let's get started. What we'll do first is define a few terms, and in particular, two main phrases, or the two key points in the title of this talk. First, C++. What is C++? Yes, I know it sounds a little bit silly defining C++ at a C++ developer conference, but it's not as simple as one would think. Because generally, you don't really think about it. So think about explaining it to somebody who has never heard about it. Well, it's a very difficult thing to do without first talking about C. Well, most likely the person who you explain to may not know what C is. So in order to explain what C is, you have to explain machine language. You have to go a level deeper. And these steps, as most of you do know, is an evolution over time where C was a high-level language as a step up, a necessary step up due to the complexity from machine language to a high-level language. And C++ is an evolution of that. So, to define C++, we could, of course, break it down into the two parts. The C, which is origin language, and the ++. The main point behind the ++, as many of you do know, is to increment by 1. I'll emphasize on this as incrementing by a single step at a time, meaning it's a language that has evolved over time, step by step by step, up to the place where it is now. Of course, due to the great effort of many, many amazing people. Some of you are watching this talk and in this room. So, the next thing we'll talk about is this phrase, developing world. You might have heard it here and there, but I'll use the Wikipedia definition, or rather I'll summarize it as it's a phrase that tries to group nations and peoples based on income levels and access to money and comfortable living due to that money. But for the purpose of this talk, I will focus in on computers. So let's discuss what the word developed means in terms of computers. Well, I guess I'll summarize it as an experience that doesn't feel slow, especially with your processors. You have enough space, enough room, hard disk room. You have enough computing power that you never feel limited. Secondly would be communication, connectivity, internet access that just doesn't feel slow. You just don't notice it. It just works. Third, very importantly, is power, uninterrupted power. We can't have computing without power. So a developed experience is one where power just works. It's just there, it's available for you, and you don't even think about it. So a side note would be uninterrupted connectivity. It is possible to have fast internet access, but that's intermittent. So it's not there it's not always there when you need it. And very importantly, the knowledge of how to make the most of these resources. And finally, all of this must come at a comfortable cost to the person using it. So now that we know what the destination is, let's talk about those that are not at that destination, meaning those who are still developing. I'll define developing as lacking in any of the developed features. So, world, what do I mean by world? Developing world. My emphasis was on world, not necessarily a country, a nation, a city, or whatever other grouping one would think of. But I'm just talking about anybody who is in a situation where they lack one of those core components, core comfortable components of a developed experience. So, because it wouldn't be fair to assume that everybody from a poor country is poor and everybody from a rich country is rich. So, the developing world is a world that is yet to attain that comfortable status. The next phrase we'll talk about is older hardware. It's something I mentioned as one of the first topics. And what I would like to talk about is generally the cost of computing hardware. As many of you do know, as time has progressed, technology has improved by making components smaller, meaning they use less energy. And this has many benefits depending on how you apply it. You could have more cores at the same power budget than before, or you could have the same number of cores using a lot less energy, meaning, for example, your mobile experience would be a lot better. So, what this comes down to is cost, because this new technology is always expensive. And when something new comes out, the older thing becomes cheaper, meaning that the expensive things are out of reach to many people, but the older hardware gets, the more people have access to it. So, how do we make code efficient for this budget or older hardware? Because it's very, very important. Because with a large number of people with less money to spend, this is a fact we cannot ignore, computing has to come at a lower cost. So, just as an aside, I'd like to talk about that lowering that cost, some of the ways that have been employed to lower that cost. One way is that computers have come in a different form, namely mobile phones, because computers have gotten small enough to fit in our pockets or even on our hands. The second way is that the older and the older hardware, last generation, 10 years ago generation, find their way into the less developed world, or rather the developing world. Also, to hit those lower price points, manufacturers often rebrand last year's high-end hardware as this year's budget offering. And in terms of connectivity, I just wanted to point out as a common knowledge or common fact that Chromebooks tend to be the budget offering. However, in areas where connectivity is not as good, Chromebooks may not work as well. So my emphasis and what I've been working with is scenarios where you have a complete computing experience where there may be little connectivity, but still have a good experience. So, software as a solution to this riddle. Software, I feel, is a very central key to solving this problem, because software performance can lift up what an older system can do. As many of you know, as hardware has been developing, software has also been developing. Our language C++ has also been developing. And I believe that it is very important to think about the low end, because that is where the people that need that performance the most will lie. It's also where scale matters, because when you're dealing with large deployments, for example, schools, governments, NGOs, most of the time they need to deploy many computers to many people, and cost becomes an important factor. So many projects to do this wouldn't even take off if the cost is too high. And software can help with this. So how does C++ in particular solve this problem? Well, first thing, by design. One of the core fundamental principles of the language is the zero overhead principle. I won't quote it here, but I will summarize it as knowing the cost of what you do. I know I've paraphrased it a little bit. But the point is being aware of what you're doing, being aware of the cost of what you're doing is something very central to the language of C++. That is its focus. It may be a bit harder to learn because of this, but at the end of the day, the end performance is of utmost importance, and this really matters when you're limited in your hardware. Well, related to that, and I'll pick on this specifically, is compile time computing. Because the less work we do on the client PCs, the better, even if there's an upfront cost while compiling. Many of you know, when doing compile time computing, you also get to catch errors and bugs earlier. And that is always a win, especially when your user may be too far away to report it to you. So const express support is also related to that. And there's also the element of parallel computing, which is aided by the stack-based model of computing in C++. I won't go too much into this because of time, but watch the famous Sean Parent talk, and especially the section where he talks about parallel computing, the structures, how you structure your code to make it be able to run on more cores. So the third reason I feel C++ is very important, and this is one of its key strengths, is the evolution from C, while still maintaining compatibility. This is very crucial because a lot of the most important software that run on our computer up to this day is actually still written and maintained in C. And to be able to improve on this, Yes, we could continue learning C or continue using C, but I think it's possible to lift up many code bases, or maybe just even bits of code here and there, into the C++ world one step at a time, improving safety and security, and in some cases, performance. So using C++, I think, is one of the safest ways also to access the functionality that is usually in these C libraries. Many libraries that actually perform very core functionality. There are graphics, the Vulkan and Direct3D and what have you. Though they're basically C-level APIs, to put that functionality together, it's better to compartmentalize it in C++ because of this compatibility. So how do we learn and teach this C++ language? How do we encourage people to use it more? Well, I have a few thoughts on this. I'm not a teacher though. I'm just someone who happens to have learned through a lot of effort. So I'll just share a few of my thoughts on this. Well, the first thing is our humanity and our diversity. That's the first angle I want to approach this as. This is something that I believe we all know. We are all diverse. After living for some time, you have literally seen diversity everywhere you go. People with different talents, heights, widths, colors, shapes, and sizes. So, C++ is a language. And I'd like to first to approach learning C++ by comparing it to human language. How do we learn human languages? Well, according to the American Linguistic Association, and in particular in the FAQ section on language acquisition, they talk about a few very interesting things about how children learn, how we learn when the language that we end up speaking. So first things first, when children are born, they have a natural ability to pick up language, like a bird learning how to fly. But very importantly, language is acquired by interaction with adults and with other children. And the stages of learning are similar in almost all children. I won't go into the steps right now, but you can look at this website to see those steps. But the thing is that there's step by step. That's a very important point, that there are steps to learning, there are steps to improving. And the adults can actually help children by stepping down a level, sometimes using baby talk, to help the children get closer to them. So how does this map to learning C++? Well, I think we need to bring more human interaction into it. I know we are doing it through our communities and our work environments, but it's to be conscious of the effect of this interaction. When somebody asks a question, our Twitter interaction, talking on our Discord servers, I just read this just a few weeks ago, but at the beginning of this year, I personally felt that yes, I have been reading and watching many videos and what have you, and I just felt I wanted to speak more and to interact with people more. So I happened to have joined the CPP Africa Discord server, and I've been chatting with some people here and there over the years, through the year, and it has been a good learning experience, even for me. And I appreciate those discussions. So the more we speak about code, interact with our code, read more code, the better we get at it. The more we hear about it, the more we talk about it. It's very important to learning C++. So we need people to be exposed to it more. Another point I wanted to just touch on quickly is reevaluating the why people use computers and programming. As with many things in life, many of us learn our computers and our programs due to reasons that often conflict with the intended design of those same programs and computers. Maybe it's a job that you're doing, you probably learned in school, or maybe you didn't really learn, you just attended a class. But I think I would like to try to emphasize that learning is a personal thing, and we need to have that excitement or see the purpose to understand that their computers can do a lot more than we thought possible. So I know we all have our different starting points. So we'll talk about how, step by step, how to learn step by step by looking at a rough roadmap that I think would be helpful. This may not be a one-size-fits-all answer for everyone, as we are all diverse, but one of the important things I have seen is that you may need to try different teachers, books, resources, and techniques before you find that right mental model for your unique personality and mind and talent. For a long time, I actually thought I was failing at learning, because I've actually learned and relearned it quite a number of times, until I understood that some of the things I grasped from this place, other concepts I got from other books, some from videos, and now I see the bigger picture, that you just have to keep on learning and pushing and exposing yourself to the language, and at some point it just starts to click. So, as part of that roadmap is to see the story. Pardon the pun. But the story of where we are coming from is very important, because this is about a step-by-step story, and it may not be possible to understand everything at first glance. You need to look to the history of different features, kind of like a movie, watching a movie in a series of movies, and seeing the whole story unfolding. Because if that story was told in one movie, probably would have been a bit of a boring movie. But there are some series where different story elements are told slowly, beautifully, and then form a great big picture. So, one thing I'll just like to note in conclusion with this is that many of the features that you see in C++ today have come from a lot of rich discussions, arguments, testing, trial and error. And something very important to appreciate, that where it is now has taken a lot of effort. So, like I said, one step at a time. The journey of 1,000 miles begins with a single step. Words of somebody wise. Can't remember who, though. Though keep a reference close at hand. Like when you go into a new city, you need a map in your pocket so that you don't get lost. One good reference is the CppReference.com website. And I'll just touch briefly that there are some basic concepts and keywords that if you don't know, make sure that you know. In my opinion, these are very important to understand. Understand expressions, statements, variables, objects, declarations, definitions, and functions. Know the difference. It took me quite a while to know what the difference was. So, briefly touch on some tooling, especially when dealing with older and constrained computing scenarios, the developing world, as I alluded to earlier. Well, one of the core things is that to learn a language, you need to interact with the language. So if we want more people interacting with language, we need more people having access to the computers, books, to power, and connectivity. And we need to think of ways of going around the current limitations that we have. So to do this, my thinking is that it is important to crawl before you walk, and to know how to walk before you run. And to do this, one of the key ways to do this is to look into the past. Look at what software was used in the past. And in order to do that, one needs to understand why we are where we are now. And in light of that, we need to not start with the integrated development environments when learning to program. Because starting out, you need to understand what is happening at the core. And IDEs are a great tool for professional environments where all the pieces come together and where time is of the essence, and they boost productivity, they help you to work really fast, but when you understand what it is that they really do. So my suggestion is to start in the terminal. Know how to run a compiler. Know how to open and save a text file and understand what is really happening. Because I think even breaking down the Hello World program, it's a program whose heart is in the terminal. Words like standard input and standard output, which don't quite make sense in the graphical user interface, so to speak. So it is also a low-cost model of teaching programming to more people in more situations because it uses a lot less resources than the graphical environments. As an aside, try to learn the shell languages, Bash or PowerShell if you're on Windows. These are invaluable. Second, keep as much as you can, as close as you can to yourself. Having what you need when you develop a machine, all the documentation, all the reference material as close as you can. If you can't have it on your machine, have it on your local network. Just have it as close as you can. It is even possible to download the entire CppReference.com website locally, or even store it on your phone. It's actually something I did 2 years ago, and it was very, very invaluable, especially when you're commuting or just sitting somewhere and just need something to read. Get reference material on PDFs. For example, there's a great documentation on the Microsoft Developer website, which I also store on my phone, and which is really good for reading because you need to expose yourself to your code and the language as much as possible. And if you can afford it, buy good books from great authors. So, the next thing I'll touch on is sharing compute resources on local networks. Of course, we all know the famous Compile Explorer, but if possible, have it on your local network. Find out how to install it. There's some good documentation on it on the GitHub page. And try as much as possible to maximize what you have. And in order to do that, there's also a crucial tool, which is the SSH Server, which is now available on Windows. And this is linked to the terminal-based computer I alluded to earlier. And it's really, really helpful in multiplying the use of a single computer, especially if you have lower cost terminals. For example, it's possible to share a single Windows computer now with basic Android phones using the SSH clients. Access to compilers, code by more people at the same time. I think this is a great saving. It's actually something I use personally because my primary machine is on Linux, but I usually SSH into my wife's Windows laptop to try out code using the Microsoft tooling. So, in conclusion, for our language, C++, to thrive and be of greater benefit, each of us must extend our hands and be as welcoming as possible to new users. We need the performance benefits of greatly written software greatly compiled software where it matters the most, on older, cheaper hardware, to make computing more accessible to more people in more places. Using older software, picking your software to match the hardware is actually one of the core things that can help us even deal with the e-waste, because we're probably throwing away too much good hardware. The personal computer can do so much more. So let us upgrade our users before we upgrade our hardware. Thank you very much.